Welcome to the Explainer. Today, we're taking on Google Cloud Platform API architecture. We're going to take some of the more complex cloud engineering concepts and map them out together. Our ultimate goal? Building what's known as a GCP API fortress. Let's get right into it. Let's kick things off with a really great quote from Tyler Treat over at Real Kinetic. He describes a massive and unfortunately common architectural flaw as Death Star security, relying on a hard outer shell to protect a soft, gooey interior. You know what he means by gooey, right? It means the second an attacker breaches your perimeter network, every internal API and service is completely exposed and overly trusting. Leaving your internal APIs vulnerable like this is, well, it's incredibly dangerous. Okay, let's dive into this structural roadmap so we can build a robust, enterprise-grade API fortress. First up, defeating Death Star security. Second, authenticating APIs with IAP. Third, creating private connections with PSC. Fourth, caching and persistent strategies. And lastly, navigating API gateway limits. Part 1. Defeating Death Star security and fixing the problem with GUI interiors. Look, a simple perimeter defense, it just doesn't cut it anymore. We absolutely must have layered security. To fix that GUI interior, we first have to understand BeyondCorp. It's Google's enterprise security model, and it was originally designed so employees could work from untrusted networks without relying on a clunky traditional VPN. Instead of trusting the network you're sitting on, BeyondCorp trusts the identity of the user and the device. This zero-trust philosophy is literally the foundation for modern defense-in-depth architecture on GCP. And that brings us to our core strategy, defense in depth. Think of this as our North Star for the Explainer. To avoid catastrophic single points of failure, like a single exhaust board on a Death Star, we have to implement authentication both at the network edge and within the application itself. That way, if one layer fails, the next layer is standing ready. Section 2, authenticating APIs with IAP, the gatekeeper. Moving into our security layer, we have to talk about our ultimate gatekeeper. You probably know Cloud IAP as a tool for securing web apps for human users, but it does so much more than that. It actually secures APIs programmatically, again, without needing a VPN. It pulls this off by supporting OpenID Connect, or OIDC. But instead of an individual user typing in a password, automated API consumers use service accounts. To make it work, you just grant that service account the IAP Secured Web App User role. Boom. Your automated systems are seamlessly authorized at the edge. Now, working with service accounts obviously means dealing with keys, and you've got two distinct choices here. First up, GCP managed keys. These live entirely inside Google Cloud, you cannot download them, and they automatically rotate every 2 weeks. They are highly secure and completely maintenance-free. On the flip side, we have user-managed keys. These are for systems living outside of GCP. You download them, they expire in 10 years, and crucially, you have to manage the rotation yourself. As an architect, making the right call here is absolutely vital for keeping your credentials locked down. Let's move to and see how this builds in practice. The complex OIDC authentication flow really just breaks down into 3 straightforward steps. First, the API consumer generates a JSON Web Token, a JWT, and signs it with their private key. Second, they send that over to Google's OAuth endpoint and exchange it for a fresh, Google-signed OIDC token. Finally, step 3, the consumer takes that OIDC token and sets it right in the HTTP authorization header of their API request. IAP validates it at the edge, and you're safely through the gates. Section 3, private connections with PSC, the secret tunnels. Okay, so we're securely authenticated at the edge. Now we need to actually connect our API gateways to our internal backends securely. When you're connecting to virtual private clouds, you usually weigh 2 main options. With VPC peering, you're coordinating subnets, managing complex routing topologies, and honestly, you're exposing your underlying infrastructure. It can be a huge headache. Private Service Connect, or PSC, is far superior for our fortress. It uses one-way communication, making it much simpler and way more private. Your underlying infrastructure stays entirely hidden from the consumer. It's basically the perfect secret tunnel. So how do we actually construct this tunnel? Say, from an APGX API gateway to an internal Cloud Run app in a totally different VPC? Well, here is the architecture snapshot. You route the traffic to Cloud Run using an internal HTTPS load balancer. That load balancer uses a serverless network endpoint group, or NEG, as its backend. And then the final piece of the puzzle. You connect your APGX instance to that load balancer using a PSC endpoint attachment on the APG side and a PSC service attachment on the load balancer side. You've just traversed VPCs without ever touching the public internet. Now, what's really interesting about this slide is how it scales. Normally with PSC, you'd have to build a separate service attachment for every single backend app you want to reach. That gets messy fast, but URL masking fixes that. It acts as a template of your URL schema. The serverless NEG reads the incoming URL, extracts the service name, and magically maps the request to the correct Cloud Run service dynamically. It dramatically minimizes the number of PSC service attachments you have to build. Truly an elegant setup. Section 4, Caching and Persistence Strategies. The Vaults. All right, we have an authenticated edge and a secure private network tunnel. But let's be real, a secure connection is completely useless if your API is dragging and users are waiting. If we're using APG, your developers need to know exactly where to stash their data so things stay fast and secure. Caches are general purpose, mainly used to store backend responses and take the load off your systems. Key value maps, or KVMs, are your general runtime store, perfect for dynamic stuff like session data or shopping carts. And yes, you can securely encrypt those entries. Finally, property sets are built specifically for static configuration data, the stuff that rarely, if ever, changes. Out of all of these tools, caching your backend responses is arguably the absolute best optimization step you can take. By throwing a response cache policy in there, you serve up data directly from the gateway. This minimizes those heavy backend calls, saves you compute costs, keeps your infrastructure scalable, and most importantly, it keeps your APIs lightning fast. Which brings us to Section 5, Navigating API Gateway Limits, the blueprint. To make sure our fortress actually stands the test of time, we have to respect the hard limits of GCP. 10 million. It's a massive number, right? That is the default request rate limit for API Gateway. Specifically, 10 million quota units per 100 seconds per service producer project. Now, because API Gateway caches so efficiently, it doesn't call service control on every single request, meaning your actual throughput can easily exceed this. But it is a crucial baseline to keep in mind. So the crucial point is, while that request volume limit is incredibly generous, the payload size is strictly capped. The magic number here is 32. You are limited to a maximum of 32 megabytes for both your request payload size and your response payload size. No way around it. If you try to push massive files through the gateway, you're going to hit a wall. Let's rapid fire through the rest of the hard architectural limits so you don't accidentally break your freshly built fortress. You're capped at 50 APIs total per project. You get 100 API configs per API. You can deploy up to 50 gateways per region. Your maximum request header size, 60 kilobytes. And finally, keep this one in mind. Streaming is natively not supported. Be sure to factor these constraints into your design. Of course, if you're building something truly massive and you actually hit these ceilings, you aren't completely stuck. To request a quota increase smoothly, just head over to the IAM and admin console. But here's a practical tip for you. Make sure to group your quota adjustment requests by product area before you submit them to Google Cloud Customer Care. Batching them intelligently like that really reduces the time it takes for review and approval. And that wraps up our architectural blueprint. I want to leave you with this final provocative question. Have you built a defense-in-depth fortress, or are you just one exhaust port away from a Death Star collapse? I really encourage you to take the concepts we explored today, from Beyond Corp and IAP, all the way to Private Service Connect and caching, and critically evaluate your own Google Cloud infrastructure. Thanks so much for hanging out with me in this explainer. Keep learning, keep optimizing, and I'll see you next time.